Yeah. Hi, everyone, and welcome to our podcast. And today we have Neda. Neda and I did PhD a long time ago together, and she is an experienced microseismic processor, or experienced geophysicist. I'm so glad that she could make it. She has a little one, but she could give us the time and have a chat with us regarding her experiences. She has a lot of knowledge in the Calgary region, so let's hear it from her. Uh,
Well,
Welcome,
nice
Neda.
to thanks for having me to Nista, and it's nice to just kind of reconnect after all these years.
Yeah, of course. So, Neda, I think we can start with your experience a little bit, maybe touch a little bit about PhDs and your job experiences, and then we can also do a little bit geophysics analysis of the areas that you have worked, maybe the data and all, the complexity of the data.
Yeah, sure. So I've my entire professional career, and then I guess academic career,
Uh-huh.
has been
Yeah.
in microseismic processing, acquisition, processing, and interpretation. So it's really data, set up as field data, being involved in the installation and the design of the array systems out in the field. For this is mostly in borehole
Mm-hmm.
microseismic, and then processing that data. That was kind of the core function. Like once we got the data set up in the field, processing the data, reviewing all that data, and then getting it mapped, and then ultimately analyzed and interpreted, and sort of providing recommendations on how to what to do with that data and what it means. So
Mm-hmm.
that's what I've been doing for I think it's about 15 years now.
Mm-hmm.
So it started in oil and gas, doing
Right.
hydraulic fracture mapping and reservoir monitoring for oil and gas fields, and then a bit of geotechnical work. And then after my PhD, I shifted to potash mining, doing microseismic, acquisition, processing,
Mm-hmm.
and analysis for potash mining. And there's lots of applications for this. Obviously, these are microseisms are, for all intents and purposes, they're earthquakes. They're
Yeah,
just
right.
smaller scale, and there's
Mm-hmm.
more of them happening than the larger ones.
Right.
They're, you know this area very well. There's just you don't feel them on the surface, but occasionally
Mm-hmm.
we do.
Yeah.
And so that's another application for some of the induced seismicity geophysicists or seismologists is dealing with regulatory issues associated with earthquakes that occur tied to operational
Mm-hmm.
operational projects.
Yeah, for sure.
Yeah.
And I know, Neda, there's so many challenges with microseismic. Can you maybe just for the audience, let's highlight those challenges that you face, maybe?
Yeah,
Mhm.
from sort of the practical side, the technical side, the processing side, or just sort of all of the above.
Uh, yeah, let's see. I would focus more on the data side, so that would be
Okay.
more like an interpretation processing side, right?
Yeah,
Yeah,
okay.
the capturing
So
data or maybe the complexity of the data.
yeah, okay. So on the I remember I used to work with a supervisor once. He always his one of his lines was garbage in, garbage out. So that's why the geophysicist always had to be involved in the field acquisition side, whether you were in the field or working with the field staff remotely. So I've always been very involved with the field staff because you want to
Mm-hmm.
make sure you get the right tools, the right sensors installed for the right job.
Mm-hmm.
Now, obviously, as geophysicists, we always want the more data, the better,
Yeah.
because especially for microseismic, we want full coverage of the focal sphere. So
Mm-hmm.
that's the ultimate goal.
Mm-hmm.
The cost of that is not always friendly to the budget
Mm-hmm.
that companies might have in mind. So um, yeah, so a lot of companies, what they end up doing is, rather than sort of doing this throwing the kitchen sink at a project at an area that they want to monitor for
Mm-hmm.
hazards or whatever, they'll do maybe one borehole array, which of course it's a very, very small, discrete sample size of what you're trying to monitor,
Mm-hmm.
which has its limitations, but it also does the intended job.
Mm-hmm.
And then to some companies will do large surface arrays, and there's challenges with that, but then you get a larger coverage of the focal sphere. So there,
Right.
and then some do both borehole and surface, and in in mines they can do in-mine seismicity monitoring, so sensors throughout the mine. So the issue on the acquisition side is always it's always trying to find that right balance between how many sensors, what kind of sensors, sample rates, where to put the geophones, how much of the focal sphere you wanna sample. Can you get the sensors close to the area that you're trying to monitor? Because that's always the goal. You want to get close to what you're monitoring, not far.
Yeah,
You want to capture the wave field as close to the area that you're monitoring, so that you're not dealing with the processing of all this excess processing of the wave field. So that's one issue. On the processing side, obviously, when I first started in the career and slightly before that, data was the data that was being acquired was limited. So you would have one array, and it wouldn't have as many sensors. As the business grew in the oil and gas sector for hydraulic fracture mapping, there was more wells. The number of wells scaled up. There was more horizontal wells, pad drilling. There was just so much. There was just a volume of data being acquired. So the software couldn't handle. In some cases, it could handle it, but it was slow.
Right.
You're trying to transfer and upload data from the field to a remote location on the server, and there's just volumes of data.
Right.
So that, there's the internet connection was sometimes slow.
Yeah.
And then that was just for the real-time analysis. So they, these clients were making real-time decisions, and there was another well being drilled. So they needed answers.
Right.
How the fractures were being propagated, so that they can make decisions on the next well that they were about to drill. So big financial decisions were being made on some of the real-time results.
Yeah.
So that was one issue. And then the other issue was the sheer volume. The software just couldn't, in some cases it was just slow in handling all the volume of data that it needed to process. And in microseismic processing, it's a very statistical analysis, so you need to process everything that you can process.
I mean, the entire length of the data you need. Okay.
Well, you need to process the microseismic events, whether it's low quality or high quality.
Okay.
Yeah. So even if it's low quality, you still want to get it on the map, because it gives you a sort of a big picture view. And then when you want to do more detailed analysis, you filter out some of the low quality data, so you can focus on some of the higher quality ones. And this gets into and you want to get that stuff processed, because sometimes the low quality events will give you will provide some trends. It'll just show you, okay, there's some activity happening. We don't quite know what it is, how much of it is happening. But we need to get it on the map, because it could yield some kind of answer in this well that maybe doesn't show up in another well. So there's just more of the anomalies that present themselves when you're dealing with low quality data. Yeah, so it was just the volume of data. So then the issue there was we needed to start automating the processing, because the human finger can only click so fast. There was just, I just remember so much clicking. And at the time, the team was discussing, okay, we were keeping track of clicks, because we needed to.
When was this Neda, like in time frame? Like
this was like like kind of the peak of it was in 2008. 2007, 2008, where it really was, really, we were dealing with volumes of data. And since then, I think it's just, I'm not sure where the industry's at now on the hydraulic fracturing side and microseismic monitoring, but I would suspect they're still doing it. Maybe they're not doing it as much, or they're being a little more selective with when and where they do the monitoring.
Right.
But there's still, there was the number of pads and wells that were being drilled happening so fast that the microseismic technology needed to be scaled up and needed to be faster and better quality. So that was happening at the time. Now, then there was so we had to start automating. And I remember specifically in this one project, we were working on developing the software to automate, to just start processing the data. but we needed to be supervised.
Right. Yeah, of course.
So
Yeah.
I remember the first project we did up in the Horn River Basin, I was involved in that. I was the analyst in the field. So I went into the field because we wanted to eliminate the whole uploading time through the satellite. So I did the processing on my computer. So I was doing all the clicks. And then we had the automatic software going at the same time with another company, and we compared results.
Okay.
And I remember the client at the end of it said, like, your results look better. I was able to get, more on the map and better quality because I was doing the QC and all of the training you have as a geophysicist. You look for all that. That's what you're trained to do. You look for, am I picking the P wave? Am I picking the S wave? What's the P wave? What's the S wave? What's the first break? Is this the right P and S wave pair, or is this a SS pair or a PP pair, or is this a
Right.
wave, or is this a converted wave? You're looking for all of that in the processing, and you're looking for the frequencies and the wave field, the wavelength, and you're looking at the photogram analysis. And so it's, if you do this long enough, you get pretty fast at it.
Right.
But that was just for one. I think it was like for one stage or one well.
Right.
But the automatic processor did a very good job considering, it was being partly semi-supervised
right
by somebody.
Yeah.
So that was another thing that came into big development. We had to develop automatic software to do the event detection. We had to train the software to look for when the P wave occurred, LTA, STAs, to trigger on actual events, and then not trigger on false events.
Yeah, right.
And then we also started training it to pick, but then sometimes the picking wouldn't always be accurate. So you had to you had to go back through the data and QC it essentially.
Yeah, right.
So I would say those were the biggest challenges. And then once you sort of got through the processing piece, you had a map. You had a map of these events, and then the next challenge there was to integrate that with all of the other data that might be present, like log data, seismic interpreted data, and try to understand, why is the microseismic moving? Why is it locating north of the well, south of the well?
Yeah.
Why is it the fracture growing in height? All of that stuff. You have got to understand where and how the fractures are propagating, so you can understand if a well starts to perform well or if it performs poorly. Can that microseismic data explain why that's happening? And then, if successful, the client wants to know, how do I reproduce this? How do I reproduce it so I can get more oil and gas out of the well?
Right, of course. So how is the stage of the technology now in terms of the softwares? Like, are they have gotten much faster? Of course, they might be working on cloud, and also they all got scalability and became faster. But how is it right now? Is it still kind of more research going on because as more data coming in?
Yeah, well, there's a number of different players in the field. So at least I know with one particular software I use, they have moved to the cloud. So it is supposed to be faster. You're supposed to have access to more kind of data, more G&G data, and it's supposed to be more at your disposal. So now the problem I always found with these big software packages is that you really have to know your way around them. So sometimes, they can be so powerful, but then if you don't know how to navigate through them, it's almost, it almost becomes a pointless to have the technology in a way. But there are super users. There's like power users, some people who know how to use these software programs very well. And there's some good, there's some proprietary software, and my guess is that they have come a long way. They have a sort of specialized or dedicated software developers, so they would have continued to develop you know, the speed at which data get processed, how it's stored, how, you know, streamlining how the velocity model and tool orientations and all that gets applied to the data, and then scaling that to handle multiple wells, multiple sensors in different locations. Because the biggest thing with these softwares often is you've got to get the sensor orientations right.
Yeah.
And you've got to know, you know, you have to make sure that your orientation is correct, and you have to make sure your velocity model is
Right.
well done. And as we know, the velocity structures in a lot of these areas is not uniform.
Right.
And so, yeah, that was always, and I'm not sure where these softwares, you know, have come in terms of modeling the velocity field, because that was always the biggest source of error. If you couldn't get that right, it was tough to get anything else, you know, accurately located.
Yeah.
So I know there was some efforts in trying to get, you know, velocity data from seismic volumes imported into the softwares, into the software. But then you always had to, you know, if you're doing that, you have to make sure it's accurate, and that wasn't always the case. And the scale of producing a seismic velocity from seismic was always different than what you needed from microseismic. So it would produce, you know, from seismic, you would get sort of larger grid spaces with velocity structure distributed. But then what you needed from microseismic was smaller grids, and you needed to know the different layers a little more in detail.
Right. Yeah. I remember. I'm remembering microseismic one course. That's one course I took with Dr. Ethan.
Yeah.
That's where it was quite difficult, to be honest.
Yeah.
So Neda, we have around 8 minutes left. But I want to ask you, since we are there, so the automation I know there was, I know Paulina, who was also, maybe you haven't met her. She was there in Dr. Eaton's group. She was also using machine learning to automate all these processes. And she's also doing an interview with me on Thursday.
Oh,
But
great.
what's the take on deep learning on these things? I know velocity model might not be the best way to approach, but are the QC being done with deep learning, like the semi-supervised ones? Are they still done that way, or improvements coming in with deep learning models?
I think improvements are. So I don't know if anybody has a perfect solution right now for handling all that data. You know, because it sort of depends on how the data is being acquired to begin with. So you have to sort of account for that. I think that automation is important, especially for microseismic data, for any kind of seismic, because anytime you've got repetition, anytime you're repeating something, I think automate it.
Yeah, of course.
I definitely think there will always have to be an element of supervision.
Of course, yeah.
With the automation.
Yeah.
Just especially in the way that the data is being used. It's being used to make either regulatory decisions that impact just sort of everyday citizens, or you're making operational decisions because clients are investing lots of money to use this information to inform their decisions. Or they're just trying to use it for safety purposes. So you have to have a human element in there always. So I don't think that'll ever go away. I think the person, the geophysicist or geoscientist or whoever it is that's handling that data should have a very good handle and knowledge of the data and how the automation and the machine learning is being applied.
Right. Yeah.
And how it's coming out. So you know, it's kind of like aviation. They're trying to automate a lot of the flying, and I don't know if I could get into an airplane where there isn't a pilot in the cockpit that could
Yeah,
I could take over at any time and has superior training to take over. So that's, you know, there's that analogy there. But yeah, so I would say there's and my thing has always been keep it simple. There's so many techniques and so many different methods on trying to automate, and sometimes you need to use different techniques. But you know, for microseismic in particular, you're often looking for the direct P and the direct S wave. So that doesn't really go away. Sometimes you want to utilize the full wave field. Maybe there's reflections and other things and refracted waves that are happening that you want to utilize. So yeah, so I mean, yeah, you need to have that person supervising it at any time when you're applying any type of automation is my take on it. And I think improvements can continually be made because not all data is made alike. Like, so I do remember one field, the automation would work perfectly. And then in another project, it just wouldn't work as well.
Yeah, if you change
because it was more noisy.
Yeah, and with my experience is if you just change the field a little bit, the data that's been trained on one field, and you just even simply move it to a little bit different location geologically, it's so different, right?
And
You need to train again on that data.
You do. Yeah, your template has to change, your master template has to change, your you know, the move out you're looking for has to, you have to train it differently to look for different move outs. Your frequency range changes. There's a lot that changes. So you have to really, that's why I say the supervision is required, and that geoscientist or that scientist or computer scientist has to know what they're looking at. For.
Yeah, for sure. So I think this was a very informative decision, Nate. Of course, there's something more we can discuss sometime to talk about a little bit, show some data, microseismics and things like that. But for now, I think we had a very good discussion on the data. I already knew that microseismic had a huge data to begin with, right? And there's always that problem. But I hope that this was quite informative for our audiences, and let's plan for a next meetup where we can also talk about some maybe some basic tools and see how, like, or maybe just do a little bit machine learning analysis and also talk about that. We can also pair up with Paulina sometime because you guys all do microseismics and it's very interesting, right? We all always talk about seismic, but this is very interesting. Thanks, Neda, for sharing all this information.
Yeah, my pleasure. Happy to have another chat
someday. Sure. Yeah, definitely. Happy to definitely have you in a next podcast.
Yeah.
Okay, thanks for now, and we'll end this podcast here.